Hello students, welcome to CSE 4 online course. I'm Shirley Roy, lecturer of CSE department, BRAC University. Today we will learn more about number theory. So let's start. GCD, do you know the full abbreviation of GCD? Greatest common divisor. So the GCD of two or more numbers is the largest positive number that divides all the numbers that are considered. For example, GCD of 6 and 10 is 2 because it is the largest positive number that can divide both 6 and 10. Just check it. So just ignore this line. In case of 6, my divisors are 2, 3 and 6, right? 1, 2, 3 and 6. In case of 10, my divisors are 1, 2, 5, 10. Right? So here you can see that there is two common divisor, 1 and 2, right? So what's the greatest common divisor from these two? This one, right? So that's why the GCD of 6 and 10 is 2. So how to calculate this GCD? If I think about brute force approach, we can use this one. Just like first, I am writing a function which will return int value, and in parameter, I will take two integers and I will find out the GCD of these two. So, firstly, I know that in case of 6 and 10, I have full idea that I have to find out the common divisor, right? So, uh, the maximum number will not have this divisor, right? In case of 5 and 10, which is the common divisor? 5, right? Greatest common divisor will be 5, right? In case of 2 and 6, the greatest common divisor will be 2, right? So most of the time, the greatest common divisor will be the minimum number of these two, or the number which will be less than both of the number. So I will start from the minimum of A and B. Just like if I try to explain this with a number, in case of like 15 and 10. So be sure that the greatest common divisor will not greater than 10, because I have to find out the common divisor of both 15 and 10, right? So the divisor of 10 will not greater than 10, right? So my first possible divisor can be 10, and then I will take for 9 if 9 is divisor of both of the integer. Then 8, no. Then 6, 7, sorry, 7, no. 7 is not common divisor. 6 is not common divisor. 5. So 5 is common divisor for both of this, right? So 5 will be my GCD. So I can just check the number reversely so that I can find the maximum possible number. This one is a brute force solution. So to do that, I have shown you a code, just like here. Uh, you will start from the minimum number of A and B, and you will decrement until you get one, until you get a common divisor. Obviously, you will find a common divisor, which will be, if you can't find any other number, you will find one. So the loop will run till greater than 0. Okay, that means till 1. So then you just will check if I can divide A and B without any remainder. So that will be the common divisor for both A and B, right? So you just need to write this one, check this one, and if it is true, then I is GCD value of your A and B. So I will just write GCD equal I and return GCD. Otherwise, I will try to iterate one by one, and finally, if any of the number doesn't match with this condition, 1 will be there because every number is divisible by 1, right? So 1 will be the last GCD of these two numbers. So what will be the time complexity? Let's check that. If you are running this loop from minimum number to 1, so the loop actually runs for n times, right? Where n is actually the minimum of a and b. So the complexity of the function is minimum of a and b in the worst case scenario. When just like 29 and 29 and 30. In case of this two number, you have to start from 29 and end till 1. So you are iterating the whole loop from 29 to 1, right? So the complexity for this number will be 29. So this is how you will find out the time complexity of the naive approach. And I will not support if you follow this because I am going to show you a better approach and this one is much acceptable. So if the Euclid's algorithm, it actually follows that GCD of A B equal to GCD of B comma A mod B. How? Let's check until A mod B equal 0. So let's calculate something. Okay. Let's say 16 and 10. Okay. So I have written the rule here that GCD of AB equal GCD of B comma A mod B. This is a formula. So if I try to find out the GCD of 50 and like 15. So I just need to write GCD of, you need to follow this rule. So you have to write GCD of 50, 15 equal will be GCD of what is the B for your number? 15, right? And for this part, you have to write A mod B, just like A is 50 and 15 is B. So A mod B, what will be the result for A mod B? 50 mod 15, right? In case of, in place of B, you have to write A mod B, right? So 50 mod 15, which is actually 5. So now, if I want to find out the GCD of 15 comma 5, I have to again write GCD of, first I have to write the B, so 5, comma 15 mod 5. So 15 mod 5, which is actually 0, right? 15 mod 5 is 0. So 0. In case of GCD of 5 comma 0, I don't need to calculate anymore because GCD of anything with 0 will be the anything. That means 5. So the GCD of 50 comma 15 will be 5. Clear? This is how it will work. So you can see that I need to write a recursive function. Just like recursive means I am going to call my own function again and again. Just like if my function is like that, int a comma int b, I just need to check if b not equal 0, then I have to calculate GCD of b comma a mod b. Else return a because b will be 0 and you have to return a. In case here is the code, there is a problem. Okay, so the time complexity is whole log max a comma b. That means you are not going to iterate the whole loop because see in the in this case I just needed to run the code for only 3 times, right? But 50 and 15, for if I wanted to do a naive approach, I would have needed 15 loops or 10 loops at least, right? So in case of 10 loops, I am writing the code within 3 loops. So what is more efficient for me? Obviously this one. So obviously follow this algorithm. you are given A and B, LCM is the smallest number which can be divided by both the numbers. For example, LCM of 15 and 20 is 60 and LCM of 5 and 7 is 35. How? So, how to calculate LCM? If I consider two numbers 15 and 20, what are the multiples of 15? 15, and that will be 15, 30, then 45, right? 45, then 60. In case of 20, what are the multiples? 20, 40, 60, right? So you can see that I have got a number which is a multiple of 20 and also a multiple of 15, and this is the least multiple of both of them, right? So 60 will be the answer for 15 and 20. So this is how actually the least common multiple is calculated. But I can follow an algorithm just like in case of if a number is called A and the number is called B, then I can just write A and B equal GCD of A comma B into LCM of A comma B. So how? Let's see. In case of 15 into 20, what will be the answer? 300, right? 300. In case of GCD, what will be the answer? GCD of 15 and 20 will be 5. So LCM should be 300 divided by 5. And the answer will be 60. That means if you multiply GCD of A and B with LCM of A and B, you will get the answer A into B. So, in case of finding out LCM, what you can do is just, sorry, from this equation, you can just write LCM, sorry, of A comma B should be A into B divided by GCD of A comma B. So you will get the answer right here. And you know how to write the function GCD. We have already mentioned that. You just need to mod the B and interchange A. Okay. So you know how to write GCD function. Using this function, you can find out LCM of two numbers. Okay. So if I tell you to find out GCD of three numbers, what will you do? In case GCD of, I want to know GCD of 5, 10, and 15. So what you can do is just like you will find out the GCD of 5 and 10 first, and then after getting this answer, you will find out the just like in case of 5 and 10, you will get GCD will be 5, right? And then again calculate the GCD of 5 in 5 comma 15. Okay, just like if I tell you to sum of three numbers, just like 3 plus 4 plus 5, what you do? You don't sum up three numbers at a same time, right? So what you do is firstly you try to sum up 3 and 4, you get like 7, and then you use this 7 to sum up with 5, and then you get 12. Okay, so this is how you can also find out the GCD of three numbers. Just trial loop one by one, find the GCD of two numbers, and then again take another number and find the GCD of the previous GCD and the new number. Okay, so in case of LCM, I guess you have understood. Just follow the same rule using a loop. Okay, now trailing zero. What is trailing zero? Trailing zero means the last, just like in, okay, sorry, just like if I tell you that I have a number called 120030, trailing zero means the zero of like right side. Okay, so there is trailing zero is 1. In case of 12000, the number of trailing zero here is 3. In case of 120, the number of trailing zero is 1, sorry. So in case of 12, the number of trailing zero is 0. 102, this 0 will not be considered because I am talking about the trailing zero, the zero which will be in the tail part of your number. Okay, so here I will show you how to find a trailing zero of a number's factorial. Just like if I talk about 5 factorial, the factorial of 5 is actually 120, right? So the answer will be there is one trailing zero, right? But I'm talking about the smaller numbers, right? 5 factorial is a small number, so I can just find out the factorial first and then just check mod, then just start to loop and find how many times I'm getting zero as a reminder, putting dividing the number with 10, right? But what about if I tell you to find the trailing zero of 20 factorial? Let's calculate that how many digits I get in 20 factorials. Okay, so calculator, 20 factorial. So see, this is a huge number, right? You can't like try a loop to, to calculate this number, right? So I have to find out a pattern or something else to find out this trailing number of trailing zero in like short loop. Okay, so I have a solution. Just like if you think about 120, okay, like 5 factorial, I have to just check how many 5 is there. 2, 5 and 2 actually. What makes 0? 5 into 2, right? So I have to check how many 5 and 2 are there. So in case of 5 factorial, there is only one 5 and one 2. So like from 1 to 5, there is actually one 5 and one 2, right? So it will produce 1 0 in the factorial number. In case of like 10 factorial, if I think about 10 factorial, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I try to find out the factorial of 10, I have to multiply all the numbers, right? In case of writing 10, I can write 5 into 2 here. So there are two 5s. So I can assume that in 10 factorial, there will be two trailing 0. Let's see, 10 factorial. See, there is only two trailing zero. Let's take another examples, just like 15. Okay, so 1, 2, 3, 4, 5. So I'm just skipping this. Like I have 5, I have 10, which is 5 into 2, right? I have 15. There is no other 3, no other 5 in this number, right? From 1 to 15. So here 1 5, here is 1 5, and here is 1 5. 3 5. So your answer will be just like three trailing zeros. So if I find out the 15 factorial, sorry, where is the calculator? 15 factorial. See, there is only three trailing zero. Okay, so how can I find that how many 5 are there in a number? So I can just divide the number with 5, right? If I divide this number with 5, it will show me, it will give me 3. So I can easily find out that there is 3 5 and my answer will be 3. But what about 25 factorial? In case of 25 factorial, if I divide 25 with 5, it will show me 5. But really there have only 5 5s in 1 to 25. Let's check. 5, then 5 into 2, then 5 into 3, then 5 into 4, then 5 into 5. So factorial, if I consider 25, there is actually 1, 2, 3, 4, 5, 6, 5, right? But 1 5 is not considered here. Why? Because this is a squared number, 5 into 5. It's considered 1 5 here. So to avoid this error, I can just check whether the number, if the number is less than, just like if I think about, firstly I will like divide 25 with 5 and then again divide 25 with 25, and then again try to divide 25 with 125. So you know, right, if I try to divide a bigger number I will get 0. So I will not consider this one, right? Because but you know, right, 125 is equal to is needed 5 into 5. So if I tell you to find out how many 5 in 125, this 5 will be excluded. And for this, I need to use this algorithm. So uh, how many times I will just divide the number with 5 into 5 into 5 into 5? When this n will be less than or equal to this one, I will start a loop and divide this with 5 into 5, 5 into 5 into 5 and also. So when the number will be less than this one, I will stop there. Just like if I show you the code, here you can see the explanation I have already told. So here I am showing you the code, just like if you keep dividing n by powers of 5 and update count until n by I greater than equal 1. That means n by 25 by 25 is equal 1, right? But 25 by 125 is not equal 1. So this loop will this loop will stop during when the value of I is 25. So don't worry about the loop problem. So you just need to write that firstly you have to initialize the count of 0. That means your count will be just like the count of 5 you have in your number, and then you just need to write a loop which will start from 5 and which will increment like the next number will be 5 into 5, then the next number will be 5 into 5 into 5, like 5 25 125, and then the other number 625. So and just count plus equal n by I. That means firstly you have to count the how many fives are there, and then you will count how many extra 5 for 25 are there, and then again you will count how many extra 5 for 125 are there. This is how you will know the total number of 5 in your number, and just you can return this count because we have already proved that if you know the number of 5 in your number from the 1 to n, then have you know the trailing number of trailing zero of the factorial of this n. So this is the algorithm for trailing zero. Next topic, actually after this problem we'll talk about puzzle solving, but before that, I mean after that we'll talk about two pointer and meeting the middle. These are two very short algorithms. I will just explain a problem using this approach, and I hope it won't be a problem. So thank you guys, and see you in the next class.